Number system is at the root of mathematics in all classes, especially 7, 8, 9, 10. In part 1, rational numbers will be explained. Very warm welcome to viewers at Raj Maths channel. We begin with the number system. We are aware of natural numbers, whole numbers and integers. Natural numbers set is denoted as n, includes 1, 2, 3, 4, 5 and so on. Whole number set includes all natural numbers as well as 0. Integers set denoted as z includes all positive numbers and negative numbers including 0. Now this is the number line. 0 and all the positive and negative integers are represented here. We define real numbers. Real numbers can be classified into rational numbers and irrational numbers. Real numbers set R, rational numbers set Q and irrational number set S. Now all the real numbers can be represented by a unique point on number line. Rational numbers are those numbers which can be expressed in the general form P by Q, where P and Q are integers and Q not equal to 0. Rational numbers include all fractions like 5 by 7, minus 3 by 4 and so on. They include all integers minus 3, 5, 7 and so on. Because we can express the integers as minus 3 can be represented as minus 3 by 1, 5 can be represented as 5 by 1 and 7 as 7 by 1. So all integers are also rational numbers. All decimal numbers, for example 0.5, 0.04 and so on. 0.5 can be written as 5 by 10. 0.04 can be written as 4 by 100. We know after decimal there are 2 digits, so 4 divided by 1 and 2 zeros. Now representing rational numbers on number line. Representing integers is no problem. 1, 2, 3, 0, minus 1, minus 2, minus 3 are well easily represented here. Now when we have to represent fractions, say we have to represent 3 by 4. What we do is that 3 by 4 is greater than 0 and less than 1. So we divide the space between 0 and 1 to 4 equal parts. 3 additional small lines we draw here. So then it gets divided into 4 equal parts. Now the third part, this here is a point 3 by 4. Now 1 4 by 5. 1 4 by 5 is greater than 1 and less than 2. We divide the space between 1 and 2 into 5 equal parts. We mark 4 small lines in between and it gets divided into 5 equal parts. Now the fourth part is 4 by 5. So this point is 1 4 by 5. Similarly on the negative side, minus half is represented here. Minus 2 3 by 5 is represented here. See here, the space between minus 2 and minus 3 is divided into 5 equal parts by drawing 4 additional small lines. And the third part is minus 2 3 by 5. Now representing 2.1. It is between the points 2 and 3 numbers 2 and 3, we divide the space into 10 equal parts, and the first part after 2 is 2.1. Representing rational numbers in standard form. See, this is a rational number 12 by 16. We simplify it and it becomes 3 by 4. 20 by minus 25, simplifying it, we get 4 by minus 5, and then we shift minus sign to the numerator, so minus 4 by 5. In the standard form of rational numbers, fractions are in simplest form or lowest term. Like this we have done, 3 by 4, 4 by 5, and negative sign, if any, is with numerator. So this negative sign is changed to the numerator. Now these two are the examples of rational numbers in standard form. Now to write a rational number between 3 and 4. Between any two rational numbers, there are unlimited rational numbers in between. So here we have to write only one. So we take the mean of 3 and 4. It is equal to 3 plus 4 divided by 2, and we get 7 by 2. So 7 by 2 is a rational number between 3 and 4. We have to find 6 rational numbers between 3 and 4. So since there are 6 rational numbers to be found, we add 1 to it and get 7, and we multiply. We write 3 as 3 by 1, 4 as 4 by 1, and multiply 7 to the numerators and denominators. For 3 we get 21 by 7, and for 4 we get 28 by 7. You can see here that 21 by 7 is equivalent to 3, because if we divide the numerator and denominator by 7, we will get 3. Similarly here, 28 by 7 is equivalent to 4, because if we divide 28 by 7, we shall get 4. Now the 6 rational numbers in between 21 by 7 and 28 by 7 are these. Now to find 5 rational numbers between 3 by 5 and 4 by 5. To find 5 rational numbers, we add 1 to it, it gets 6. Then 3 by 5, we multiply 6 to the numerator and 6 to the denominator. Similarly here, 4 by 5, multiplying 6 at numerator and denominator. We get the fractions 18 by 30 and 24 by 30. See, 18 by 30 is equivalent to 3 by 5, and 24 by 30 is equivalent to 4 by 5. Now between these two rational numbers, it is easy now to find. We have to note here that denominators are same. So just by increasing by 1 the numerators, we get all the rational numbers in between. 19 by 30, 20 by 30, 21 by 30, and so on. Now to find 7 rational numbers between 0.6 and 0.7. 0.6 can be written as 6 by 10 and 0.7 by 7 by 10. Now 7 rational numbers between 0.6 and 0.7 are 0.61, 0.62, 0.63 till 0.67. All these are between 0.6 and 0.7. Then we write these decimal numbers as rational numbers. 61 by 100, 2 digits after decimal, so 1 and 2 0. Like this we write all these numbers. Now these 7 rational numbers are in between 0.6 and 0.7. See, we have just shown the example between 0.6 and 0.7. We had to write 7 rational numbers. we had taken 0.61, 0.62. Now we can alternatively we can choose the numbers as this: 0.611, 0.612, 0.613, like this, and write it as fractions. 611 by 1000. After decimal there are 3 digits, so 1 and 3 zeros. So 612 by 1000, and like that. Actually, between any two rational numbers, there are unlimited other rational numbers. We have just written 7 here. We can write in thousands and in lakhs. So you have to give whatever you feel. It should be between the two given rational numbers. But actually the rational numbers may not be the same answer with every student. You can have your own answer and somebody will have a different answer. But all the answers will be acceptable. Addition, subtraction, multiplication, division of rational numbers have been covered in basic maths up to class 7. If you see the playlist of videos up to class 7, then you can see all addition, subtraction, multiplication and division. There was a slight mistake here. Up to class 7 videos, please note. This is all about the rational numbers. In our next video, we shall discuss about irrational numbers. See you till then. Goodbye.